start. All right, so my name is Shelbi Schimpf. I am a telescope operator with the SMA. I was a helo-based operator for 5.5 years. I'm now the lead second shift operator out in Cambridge. I will be going through a continuation of Jeff's talk, a sequel, if you will, where the scripts strike back. This is going to be talking about scripting for the SMA. This will be talking strictly from an operation standpoint. You guys have been talking about the science behind using the SMA. You've been doing that for 2 days. There's a lot of other people that can answer better questions about the nuances of doing your scripts. This will be strictly from an operator standpoint and going through the script generator. Okay, so you followed all of the tools and everything from the previous talk, and you have been accepted for your proposal. Now, what do you need to do? You need a script. Okay, so what we're going to go through in this talk is using the script generator on the SMA Observing Center to create your script, going through the mechanics of what the script actually will do, and some tips and hints. Okay, the last couple nights of observations have been weathered out. It looks more promising for tonight. So you'll get a lot of information about a script today, and then hopefully you'll be seeing it in action in a few hours. Okay. So with the SMA, all of our scripts are in Perl. It's just the output from the script generator. We have a general for 90% of our observations is going to be this general script format. You do an initial flux and bandpass calibrator, then it sets up your science loop, and then you do a final flux and bandpass calibration. Exceptions to this rule will be polarization tracks. Those are their own separate beast. And some of the mosaicing scripts will be slightly different as well. Other parts that are put into our scripts, you used to have to specify what kind of pointing structure you wanted with your script. Now we have automatic pointing worked into the subroutines of the observing scripts. The pointing structure for us now is when the sun is up, we point every 30 to 40 minutes. When the sun is down, it points about every 3 hours. And sources are automatically picked by the pointing script. Then we have, some people will need transit calibrators. The upper elevation limit defaults for SMA scripts to 83 degrees. If your target source goes above 83 degrees, you will want to pick a source to observe when your target source is unavailable. You can use that for extra bandpass calibration, additional gain calibration, and that can all be specified with the script generator. All right, so the SMA OC, this toolbar will look different depending on what kind of access you have to the SMA OC. If you're staff, you'll have most of these. If you are a PI, you'll have some of them, but the main thing is going to be the My Projects. Okay, this is where you're going to be submitting your proposals. Jeff talked a little bit about that in the actual with the actual proposal part in the previous talk. So if you click on there, you will get to your SMA project page. This is where it's going to show all of the projects for which you are a PI, a co-I, or an authorized user. Each project is going to have its own code. Depending on what you've been allocated for time, your project may have one track, your project may have several tracks, but they will all be separated by the different project codes. Okay. So for my awesome project, you can click on the project code there, and that will get you to that individual project page. Again, at this point, if you have multiple tracks for your project, they'll all be listed here. For my project here, I just have the one track. It will also show the status of your tracks. If you have multiple tracks, some may be completed, some may be scheduling, some may show they need a script. The biggest takeaway from this talk should be, if you don't have a script, you won't get time, okay? So if you want to create your script, you can go to Track Overview and Script, and this will bring you to the track or the script page for that particular track. Again, I don't have a script, so I won't be able to get any time, but I can create one using the script generator, okay? Here's a bandpass visualizer. Again, this is also a plot that I really don't know much about, but Carter wanted me to put it in there because it is a very handy tool for when you're planning your observations. Okay. Also, all of the tools that we were talking about earlier can be found up here. There's good ones in the preparing observations, in the tools, that's where you'll find the calibration list and these things as well. Okay. So you click on generate a script, you'll come to this page. Some of this information is going to be propagated from your proposal, but you can adjust all of these. So this is where, again, where you specify your frequencies. As Rob mentioned yesterday, we are constantly, every night we observe dual frequency. You have a receiver A, which is the 230 receiver or the 345, and you have a receiver B, which is the 240 gigahertz receiver or the 400. Okay, you pick your sideband, you pick all of those things. Each of these links is an information page. You can click on that and get more information about the different topics. Okay. Integration time will default to 30 seconds. The majority of SMA projects are 30-second scans. The way our swarm correlator works, every 30 seconds we're recording data. The scan might be flagged bad if you're changing sources. It's probably going to be, it'll be flagged bad if we do a T-sys measurement where we put the ambient load in the beam to calibrate the T-sys. But every 30 seconds a scan is recorded, whether it's flagged good or bad. Some polarization observations usually use shorter scans. Some mosaicing projects use shorter scans, but default is usually 30 seconds. Okay? You can select your number of target sources, number of gain cals, flux, bandpass, all of that. Here we have advanced observing options. If you are doing a mosaic, the scheduler highly recommends using the mosaicing tool rather than specifying, if say you have 7 different pointings you want to do, use the mosaicing tool rather than specifying 7 different target sources up here. One benefit to that is with the mosaicing, it doesn't do a T-sys measurement between each of the pointings. If you put them as separate targets, it'll do a T-sys in between, so you run the risk of losing at least an extra scan in between each of your target pointings. Okay. Observing loops, normally people have one observing loop, even if they have 1, 2, 3 sources. This is a good tool to use if you have multiple sources separated in the sky. That way you can, if you're tracking one source till it sets, then you have a second source that rises later, you can specify the observing loops using LST ranges. And that way you'll just follow the one, and then when it's time to switch to the other, the script will automatically do that based on the LST. Okay. When you specify all those, you'll go to proceed. Okay. So this is where you actually name the targets you want to observe. For me, I'm just calling mine science target. I put in RA index there, and then I'm specifying 30 scans on the source each time we go to observe it. So with 30-second scans, it's going to be 15 minutes. This is where you can specify your gain calibrators, the number of scans you want on each of them. And then this is, the bread and butter of your script. This is where you specify the observing sequence over a loop. If you have one target, it's usually a gain cal, target, on and on over the course of the night. If you have multiple sources, you can do one gain cal, target 1, target 2, second gain cal, target 1, target 2. These are, again, the nuances of the scripts that other people will have better information about. But for this is just telling what you want the script to do. Okay. If on the previous page you did multiple observing loops, you're going to have multiple sequences that you have to specify. All right. For flux and bandpass calibration down here, you can name what you want to do for those, but don't stress too much about those. Remember, when you're preparing your script, depending on when your source is available, you might put your script in, it might not get observed for a week, for a few weeks, for a few months. At the time your script is actually observed, whatever you choose as your flux calibrator might not be available on the night that you're observing it. But one of the jobs of our scheduler is when he schedules a track, he will go through and he will optimize your flux calibration and your bandpass calibration to take optimal use of the time available. If we observe your source at a time when it's rising early, he'll put all the flux calibration at the end, so we're on your source as much time as possible. If we're observing your track at a time when your source rises at midnight, we'll front load the script with all the calibration so we can spend as much time on your source as soon as it's available. Okay. Transit source. So this is where if your source is one that goes above the elevation limit, you can specify what you want to observe while it's unavailable. And the pointing frequency, Again, this is just informational purposes, but right now we have automatic pointing, so you don't have to worry about that. All right, so choosing gain calibration, you had a whole talk on this morning. I refer you back to Mark's talk, but again, the general rules of thumb, something nearish to your target. You want it bright enough to be detected. Mark went through having two or multiple gain calibrators over the course of your loop. How often you go back to your gain calibrator depends on the brightness, the configuration. And again, when in doubt, calibrate more. If you have multiple tracks for a project and you realize in your first one you calibrated way too often, you can adjust it for your next few tracks. But if you don't have enough calibration, you can't go back and get more. So, all right, so when you continue on from here, you continue on with the script generator. This is where you can check to make sure the script is going to do what you want it to do, okay? It gives you how much time you're gonna have on source, how much time you're gonna have on your calibrators, the summary of your observing loop. So when you put in the sequence, this tells you what it's actually going to do. You can look at that and say, oh, I want, I can go 20 minutes between calibrators. You can go back and change that. Or if you think, my calibrators are weak, I should probably calibrate more often, you can go back and change that. So this is where you can make sure it's going to do what you want it to do. The next most important thing is to simulate your script, okay? The script simulator just defaults for the next available observing day. So I created this screenshot a couple days ago. We normally start observations at 4 UT each night. So it'll just put 4 UT for the next observing day. You can adjust this. If you know your source isn't available for a few weeks or a few months, you can change that time. And then if you hit simulate the observation, you come to this page. And what it does is it will give you output, which is similar to what the output will be when you're actually observing. Hopefully you'll get to see these in the next couple of nights. But this gives you a chance. You can scroll all the way through. It'll give you a chance to see that, the observe command is sent to send the antennas to the calibrator. It shows you that it's doing the number of scans you wanted. It goes to the science target. It makes sure the loop is going properly and the way you want it to be, okay? And then this down here is the actual script, which will be placed in your project page and which will be used when we actually observe your project. Okay. Excuse me. And then once you are happy with it, you go back to it takes you back to the track overview page, and then this is what you'll see. You'll see that you have a script. You'll see that it's available to be scheduled, and any observation, anytime it's been scheduled, that will show up in the scheduling page. It'll show if it's failed, if it was successful. It'll give you a link to the observing report. And then at this point, once you have a script on, you can go back and make edits in the script by managing it directly. There's some things you can't necessarily edit. If you were allocated time for a particular frequency, you can't go in and try to get a different frequency because that's essentially getting a new project. But if you realized, oh, I do want to get 40 scans on my source and 10 on my calibrator, you can go in and do this and change it right there. All right, and so some hints and tips from an operations standpoint. Get your script in early. When the postdocs come through Cambridge, when any pre-docs come through, that's the thing I always tell them is get your script in early. On the tools page of the SMA OC, it has the configuration schedule. I would say if you know your configuration's coming up soon, get your script in, because how the scheduler determines what's being observed is the highest ranked track for the weather that has a script. First couple of days of a configuration change, a lot of the projects won't have scripts in, so he has to go to the project that has a script in. I know people that got much better weather than they were allocated. They had time from a much lower ranked project because theirs was the only one that actually had a script in. So definitely get your scripts in early, and it gives you a better chance of getting your track observed. Okay, gain calibrators. Again, there was a whole talk about that. Just pick calibrators that are close, that are detectable, and make sure you're going back to them as often as you feel you need, okay? Flux and bandpass calibrations. Again, the takeaway from this is don't sweat it too much. We have, a handful of good flux calibrators. We have a lot of bandpass calibrators. Those will be adjusted on the day your script is actually being observed, okay? Simulate your script. Make sure your script is doing what you think it should be doing. we operators, we will make sure the script does what it's supposed to do, but we're not necessarily sure if what it's supposed to do is what you wanted it to do, okay? So we can only do what the script tells us to do. So simulate your script, make sure it's doing what you want it to do so you get the observations that you want, okay? And as with giving proposals, proofread. We have an entire time loss section for script errors. Most of those are typos. They will be people who, if you put extra spaces in the source name, we've had people forget to put how many scans they want taken on their source. We've had people put the wrong coordinates and then completely miss a detection of their science target because they put the wrong coordinates in or they had a typo with that. So just make sure you do that. It'll save you time, it'll save headache, it'll make the operator's job easier, and it'll make sure we can get you the data that you propose for and that you want. Okay. Questions about the scripts in the script generator can be sent to Glenn Pettipaw. He is in charge of that, or your internal contacts at the CFA, AGA, or IFA. And we operators are also happy to help with any scripting questions that you have as well. Okay. Any questions?
I might have missed it. Does script simulator simulate it for the time that you enter you're supposedly doing the observation?
Yeah, there is a time, you can specify what time you want it to simulate. It will default to 4 UT for the next observing day, but you can change that. So if you know your script's not up for a few weeks, you can try it for a few weeks later, you try it for a few months later, you can just specify the time. So, and it's the same thing that Glenn will do when he schedules a track. He'll simulate it that night to make sure, so we see what's supposed to be happening as well. Okay.
Will the simulator catch those typos, the spaces and extra things?
It will show an example, like when I had someone who didn't actually specify the number of scans they wanted, it will show up as observe and then it'll show up as integrate with no scan number. So it'll just skip it. So it will actually go to the source, but it won't take any scans. It'll just go to the next thing. So if you're looking through, you can see the timings and you can see that, oh, it actually didn't spend any time on that source. It just went to the next thing. And once you actually see the simulation, if you look through, the screenshot would make it kind of hard, but if you're scrolling through, you can see it. And it's pretty straightforward, even if you're not familiar with the format of the script. Just seeing the output, it has the simulated UT times, and it's up to date. So it's straightforward when you're actually looking at the simulation output. Yeah.
So the target name that you enter there, is that what's actually going to show up in the archive in the future for other people to find? And are there
Yes. Yep.
rules about that? I guess don't name it like box 1.
Yeah. I don't know. Are there any rules to naming?
There are no rules because I don't think we've ever had to enforce any rules. So for one, keep in mind that it is nice for people in the future to be able to see those data sets. The data are proprietary for a period of, I think it's 18 months after your observations are done.
15.
15. Yeah. Sorry, 15. And so you might be done with your data set, but somebody else might have some interest in trying to mine it. And sometimes it's nice to be able to just search for things by name. That being said, a lot of stuff that we do is searched by coordinate position, not so much by name. No one is, name it whatever is going to make sense. We mostly use those names to just have some idea, or at least I use those names to recognize whether or not we're looking at a calibrator versus a source. So yeah, if you put in something that looks like a phone number, I generally think it's a calibrator. If it doesn't look like a phone number, I assume that it's a source. But
Yeah, and hopefully you guys will be able to see these in action the next few nights. And then, yeah, at least tonight, yeah. And then, yeah, we can do that, and then you'll see some of the output, and this will make a lot more sense. All right, thank you.